Warm welcome to all of you. On behalf of Indian Institute of Soil and Water Conservation, Dehradun, I am welcoming all viewers for this video lecture. The lecture topic is Agroforestry System for Soil Health Improvement. This lecture is delivered by me, Dr. S.C. Hombe Gowda, Senior Scientist working at ICAR-Indian Institute of Soil and Water Conservation, Research Center, Ooty, Tamil Nadu. Coming to the background of today's lecture, as we know, world food production was increased during the Green Revolution period, mainly because of the intensification of agriculture, such as mechanization, use of chemical fertilizer and pesticide, irrigation, and use of high-yielding varieties. That time, it was highly necessary to feed our growing population. But this intensive agriculture comes with cost also, like fertilizer, excessive fertilizer entered our environment, polluted our water bodies. Excessive use of pesticide and insecticide affected human and ecosystem health. Nutrient and intensive tillage resulted in lower organic matter in all soil agricultural lands, and totally it has affected soil properties and reduced the productive capacity of the land. But with this negative thing, can we stop our intensive agriculture? No, we cannot stop our intensive agriculture. Only thing is that we can think of alternative technologies to improve and sustain our soil. This graph shows the use of nitrogen fertilizer in the developing countries versus developed countries over a period of time. Before 1990s, developed countries, they were using high quantity of nitrogen fertilizer than the developing countries. Due to the negative impact, they were started using the reduced the quantity of fertilizer after 1990s. Whereas developing countries, still they are using the high quantity of nitrogen fertilizer to meet their production demand. This graph shows the emerging nutrients deficiency in our agriculture soil. Before the Green Revolution, our agriculture soils were efficient for one or two major elements, nutrient elements. Whereas during the Green Revolution, we started producing high quantity of products, but without replacing our nutrients in our soil. Hence, the deficiency was increased. Presently, we have around 10 essential nutrients are deficient in our agriculture soils. Due to the intensive agriculture, the soil health becomes slowly deteriorated, and the productivity becomes saturated, and that's why the Green Revolution became dull. So people are looking for the different technologies where they can maintain the soil fertility. Example, agroforestry, natural farming, zero tillage, or organic farming. Here, agroforestry techniques are based on the idea that tree increases the nutrient cycling. So firstly, they absorb the nutrients from the deeper layers, and they improve the soil fertility through addition of leaf litter in the soil surface, and improve the microclimate modification like temperature reduction, wind velocity reduction, relative humidity maintenance. So these improved microclimate that supports the crop growth. And also the agroforestry act as a buffering the effect of climatic extremes like a flood and drought period. During that period, the productivity will be maintained. So if you look at the definition of the agroforestry practice is an important land use management intervention which integrates trees into an agricultural land with or without animal component. So if you say simply, so we are jointly we are growing agricultural crop as well as the tree species in a same unit, land management unit with or without animal component. So this agroforestry essentially a mixed cropping system, and it implies coexistence of agricultural crop as well as the tree species and or with or without animal component. As we know, agroforestry is not a new technology. It was practiced thousands of years back in the tropical region, and it is considered as a sustainable because it provides products and materials constantly, and it's considered as a multifunctional basically because of the productive, like it provides multiple products like fuel, fodder, timber, medicines, fruits, and etc. And it is considered productive also because whenever there is any crop failure, it provides immediate returns to the farmers, and basically it improves the soil properties like addition of leaf litter as well as the protection of the soil from the erosion, and it's an important source of the biomass which is produced through leaf litter provides the important source for the soil organic matter. And agroforestry is structurally and functionally more complex than the simple monocropping or tree monoculture. Friends, let us see what is the mechanism of soil health improvement by the tree species in the agroforestry system. First and foremost is that agroforestry enhances nutrient cycling and improves the soil fertility. The soil fertility was basically improved with the biological nitrogen fixation by the tree species in the agroforestry system. As we know, tree fixes atmospheric nitrogen through symbiotic microbes such as rhizobium and trachea, which is present in the root nodules. Around 600 rooty species they fixes the atmospheric nitrogen in soil. Among the agroforestry, ICAR-IISWC fixes 40 to 80 kg of nitrogen per hectare per year, whereas leucocyphelia fixes 260 to 320 kg per hectare per year. The second activity where the soil fertility was improvement is done is the tree leaf biomass production, its litter fall and its decomposition. In general, the tropical agroforestry system produces leaf biomass around 2 to 12 ton per hectare per year, depending on tree species and density and tree management. Whereas leucocyphelia fixes produces the biomass of 4 to 10 ton per hectare per year, whereas the Grillicity CPM produces 3 to 12 ton per hectare per year. This produced biomass is going to add around 50 to 200 kg of nitrogen, including the other nutrients, into the agroforestry soils of the agroforestry systems. Let us see that the other functions of trees which improve the soil fertility is that tree uptake of nutrients from deeper soil layers. Tree absorbs and pumps nutrients upwards from deep soil which are beyond the limit of root crops, where they are returned back to the topsoil through litter fall, root turnover as well as the decomposition. Additionally, tree roots acts as a safety net, intercepting mobile nutrients such as nitrate that would have otherwise leached away from the system. And the other activity is that mycorrhizal association of tree species, which improves the effective root zone, which can absorb the immobile nutrients such as phosphorus. The fourth and final activity which improves the soil fertility is that the conservation of soil and water resources and soil amelioration. As many studies reported that agroforestry system reduces the soil as well as the runoff from the system. Additionally, it protects the loss of the other nutrients, especially soil organic carbon, nitrogen and phosphorus, which is reported in many of the experimental plots. This is the schematic representation of nutrient cycling in agroforestry system what we studied during the last two slides, where first activity is that biological nitrogen fixation, second is the absorption of the nutrients from the deep soil layers as well as the leaching material, and pumping and addition of nutrients through litter fall and its decomposition. This slide shows the second mechanism involved in soil health improvement by tree species in agroforestry system. Agroforestry systems, as we know, improves the soil physical parameters with the following activities. Organic matter addition in the agroforestry system through litter fall and pruned biomass and their decomposition increases the soil organic carbon, which leads to the improved soil aggregation as well as the reduced bulk density and enhanced water holding capacity. And also the tree cover reduces the soil compaction and improves the soil infiltration, leading to the better soil structure and aeration. Overall, the improved soil physical parameters such as porosity and moisture retention enhances the infiltration, water holding capacity and reduce the compaction, makes soils more resilient in the arid and semi-arid region during the adverse climatic condition. The third mechanism of soil health improvement by trees in the agroforestry is that improvement in the soil biological health. Agroforestry boosts the soil biodiversity by providing the habitat and food for microorganisms, earthworms and mycorrhizal fungi. The higher biomass, microbial biomass and activity accelerate the nutrient mineralization in agroforestry system and enhances the nutrient availability to the agricultural crops. And the third, the increased functional diversity of microbes strengthen the soil fertility and crop resilience in the agroforestry system. The fourth mechanism of soil health improvement by tree species in agroforestry is that improvement in the soil organic matter as well as the soil organic carbon sequestration. The agroforestry added leaf litter, pruned biomass, root residues and root exudates adds lot of organic matter which decomposes into humus and enhances the deep root soil carbon sequestration. The improved organic matter in the soil which promotes the soil aggregation, protecting the soil organic carbon and from the rapid decomposition and facilitating the long-term storage. The tree cover reduces the erosion, carbon loss in the system, while the deep root species transfer and store the carbon in the subsoil layers of the agroforestry system. According to the many studies, the carbon sequestration ranges from the 1.5 to around 3.5 ton per hectare per year in the tropical agroforestry system of the world. Fifth mechanism of soil health improvement by tree species in agroforestry is that improvement in the microclimate as well as the soil moisture. The tree canopy provides the shade, lowers the soil surface temperature, reduces the evaporation losses and moderates the extreme heat, wind and radiation in the system. The improved soil physical parameters also improves the water holding capacity and reduce the surface runoff. The deep root system access the subsoil moisture and recycle the water and nutrients to the upper soil layers where this moisture and nutrients available to the agriculture crop. Many case studies are reported where there is improvement in the soil moisture in the agroforestry systems. The sixth mechanism involved in soil health improvement by the tree species in agroforestry is that soil erosion control. Many studies are reported that agroforestry species are effective in controlling the soil erosion as well as the runoff. The mechanism involved in the soil erosion control is that canopy interception during the rainfall and the ground cover, which reduces the runoff. The root reinforcement and soil binding, which controls the erosion from the running runoff water. The third activity is that improvement in the physical parameters such as soil structure, soil organic matter that enhances the infiltration and decreases the surface runoff and minimizing the erosion losses during the agroforestry system. There are many studies reported that whereas allocropping, it can reduce up to runoff 29% and soil loss from 45 to 49% in the tropical region of the India. Coming to the summary of the today's lecture is that agroforestry systems plays a vital role in improving soil health and sustainability of land by enhancing soil physical properties, increasing the soil organic carbon, moderating microclimate, improving soil moisture availability, and effectively controlling the soil erosion. And also agroforestry not only conserves resources but also enhances the long-term productivity, resilient and ecosystem services essentially for sustainable land management in the tropical region. I thank all the viewers for watching this video. Thank you.